Alrighty guys, welcome back to your remote learning experience. This lesson is going to be for Wednesday, April 22nd. So hope you guys had a great Tuesday, had a great flex day. You were able to get some work done, able to make up anything that you were missing. I'm still missing this document from quite a few folks. This is our one-step mole conversions practice. The only reason I'm grading these is just to make sure I can give you guys feedback on them and make sure that you are prepared when it comes to our quiz, which is going to be tomorrow, which is Thursday. Okay? So, I was able to give you guys feedback on, I think, all of the documents that I got. And I wanted to kind of go over a few things, just some things that I've noticed about some of the practice problems and some things that some folks have had a little bit of difficulty with. So yeah, without further ado, I'm going to get right into it. So I'm going to go over a few one-step mole conversion problems and also maybe like one two-step mole conversion problems. Your quiz is going to have both one and two. Actually, I don't know yet. I'll let you know. But you are going to have some sort of mole conversion problem on your quiz. It might not hurt just to do one two-step mole conversion problem, but we'll see. Okay then, so what I wanted to go over was one of the conversions that I've noticed some folks have had a difficult time using. And to do that, I'm going to pull up this PowerPoint really quick, because this is the PowerPoint that we've been using. Give me a second for it to load, to go back to the bottom. Where is it? Aha. So this is kind of your mole conversions note card. You should have a note card with these 4 basic conversions on there, okay? So a lot of people have been doing a really good job knowing when to use this first conversion, which is converting from moles to particles, those particles being atoms, ions, units, or molecules. People have also been doing a really good job from converting between moles to grams, and that gram formula mass is just that number right under the periodic table. And then also people have been doing a really good job converting from moles of a gas to this 22.4 liters right here. Okay, so converting with moles of gas that are involved at standard temperature and pressure. The one unit I think that we're still working on is this last one, or last conversion, which is that 1 mole of a compound is equal to X moles of the parts of the compound, okay? And that X represents the subscript in the compound's formula, okay? So like in this example, when I have 1 mole of carbon dioxide, all right, if I look at that subscript right here next to oxygen, that means I have 2 moles of oxygen, okay? And I also have 1 mole of carbon. So there's no subscript next to carbon, but just we can assume that there's an invisible 1 right there and that there's 1 mole of carbon in carbon dioxide, okay? So I'm going to go over a couple that you guys had as practice problems. I'm actually going to go over number 3 and number 4 because I think those were the ones that people had the most trouble with, or I got the most questions on too. Okay, so this first one, number 3, is asking me to convert from 1.28 moles of NH3 to moles of hydrogen, okay? So I'm going from moles of a moles of a compound to moles of a part. Okay, so the easiest way to kind of identify when you're going to need that very last conversion factor on this note card is when the formula that you are given, which in here is NH3, and the formula that you need to find are not the same, okay? Anytime that happens, you're probably going to be using that very last conversion factor, okay? So when this formula and this formula are different, okay, then you are going to be using conversion factor number 4 on your note card, okay? So all that means is that 1 mole, for every mole of NH3 that I have, what I'm going to do is look at the subscript that's next to hydrogen, all right? And that's a 3. So that means for every mole of NH3, I have 3 moles of hydrogen, okay? And this is going to be the kind of conversion factor that I'm going to be using in this problem, okay? So all I would need to do is set up my handy dandy box, which I've done before in our previous videos. Okay, I'm going to put my given value in the top left corner per usual. So that's 1.28 moles of NH3. And then my conversion factor is going to go in these next 2 boxes, okay? Remember, the one I'm converting to, or my find unit, is going to go on the top, okay? So I'm converting to, or I'm trying to find moles of hydrogen, so I'm going to put this in the top box. All right, and this is the unit I'm converting from, moles of NH3, so I'm going to put that in the bottom box. Okay, and this box is not going to be used. So now all I have to do is multiply those top 2 boxes together and then divide it by the bottom box. All right, so pretty much all I'm doing is taking 1.28, multiplying it by 3, and then dividing by 1. Okay, well, I'm going to do that on my phone. 1.28 times 3 divided by 1, which is 3.84 moles of hydrogen. Remember, these units will cancel out, and this is what I get. Okay, so that would be my answer for number 3. Okay, so I think this is a good example to use for the very last conversion factor on your note card, because I think that one was a little bit difficult for some folks. Okay, so now I'm going to go over number 4, and then I'm going to do 1 2-step conversion problem and then let you guys go for the day. Okay, so moving on to number 4, which I am given 2.98 moles of sodium, and I'm trying to find how many moles of sodium phosphate there are, okay? So remember, if the formula for the given and the find are not the same, I'm going to be using that very last conversion or very last equality on my note card, which is that, oh, go away. Which is that 1 mole of a compound equals X amount of parts, okay? So that means I first need to figure out how many moles of sodium phosphate I can make with moles of sodium, okay? So this one's a little bit confusing because we're actually dealing with the part of the compound first, and we're trying to find the whole of the compound, okay? But the process is pretty much the same, okay? So all I'm doing is I'm looking at this right here, and I see that for every mole of sodium phosphate, oh crap, here we go. For every mole of sodium phosphate, I have 3 moles of hydrogen. Of sodium. Okay, because of that 3 that is right next to sodium. Okay, this is going to be my conversion factor. Okay, so it's pretty much the same setup as the last problem. Okay, I know it's a little bit confusing because the part of the compound is in the given and the whole compound is in the find, but the process is really the same. Okay, so I'm going to use my handy dandy box to set this up. Okay, my given is always going to go in that top left corner, so that's 2.98 moles of sodium. Okay, then my conversion factor is going to go in this area right here. Okay, so where do I put which kind of unit? Okay, so remember the unit I'm converting to always goes on the top, okay, or my find unit. So I'm trying to find how many moles of sodium phosphate I have. So that means this one right here is going to go on top. 1 mole of sodium phosphate. Oh, wow. Could not have made a worse 3. Okay, and then the unit I'm converting from is going to go, I'm converting from moles of sodium on the bottom. 3 moles sodium. Okay, so same step as last problem. I'm going to multiply the top 2 boxes and then divide the product of that by the bottom box. Okay, so I'm going to take 2.98, multiply that by 1, and then I'm going to divide that by 3. And when that happens, I get that I have 0.993 moles of sodium phosphate. That would be my answer. Okay, and that makes a lot of sense because for every mole of sodium phosphate, there's 3 moles of sodium, okay? And right now I only have 2.98 moles of sodium, so I don't have a full 3 moles of sodium that would be needed to make 1 mole of sodium phosphate, but it's pretty darn close. So 2.98 is very close to 3, so that's why this value is very close to 1. Okay, so this value does make sense when you look at your given and your find and the conversion factor. Okay, so I wanted to go over those 2 examples because I think those kind of stumped people. And make sure that you do keep in mind when the given formula and the find formula are different, you're going to want to use that last conversion factor on your note card. Okay? So I'm going to do one example with a 2-step conversion problem, and then we're going to be done for today, and you can use the rest of this time to help you review for your quiz tomorrow. Okay, and for your quiz tomorrow, you're only permitted to use a calculator and your conversion note card. Okay, and that is it, nothing else. All right, I'm actually gonna clear all drawings. Perfect. So now I'm going to go to this sheet, which is one that I assigned to you. There are some 2-step conversion problems on here, and I just want to go through one of them with you so that you can understand what's going on here. Okay? So try to get this in by Wednesday at 11:59 p.m. Again, this is just for your practice. That's the reason why I grade these, is so I can hold you guys accountable and know that you are putting in the practice time that's necessary to help you be successful on the quiz. Okay. Also, there are quite a few practice problems on here that incorporate some of the examples that I just did to help you get some more practice on those, because I think that everyone could benefit from some of those problems. Okay, so now we're going to move on to a 2-step mole conversion problem. Okay, so I'm actually going to do the first one, and then the rest I will leave up to you guys. Okay, so looking at this problem, all right, I am given 4.21 times 10 to the 23rd grams of chromium, okay? And I need to find how many atoms of chromium, and I need to find how many grams that is equal to, okay? So what I'm gonna do is look first at my note card, because I've already given you guys the given and the find, which is our first step. So I'm gonna go back, oh, crap, why do I always do this? Get out of the way, stupid bar thing. All right, I'm going to look at this note card and see if there's a direct conversion from atoms to grams, okay? And it doesn't look like there is, okay? But there is a conversion factor that has moles to atoms and moles to grams. So these are the 2 conversion factors that I'm going to be using in my 2-step mole conversion problem, okay? So I'm going to use number 1 and number 2, okay? And apply that to this problem in particular. So I know that 1 mole of chromium is equal to 6.02 times 10 to the 23rd atoms. Okay, so this is just using the very first conversion on that note card and applying it right here to this specific problem. Okay, and that's that 1 mole of any substance is equal to 6.02 times 10 to the 23rd particles. And the particles in this case are atoms. All right, and then the second one is that 1 mole is equal to the gram formula mass, okay? So all I need to do is look at the periodic table real quick. Oh, stupid thing. No, let me live my life. There we go. Periodic table. Sorry for the writing that's in the way. Chromium. Where are you? Chromium. Chromium. Right here. So, of course, that's in the way. The gram formula mass of chromium is 51.996. I'm actually just going to round that all the way up to 52.00 just to make things a little bit easier. Okay, so that means 1 mole of chromium is equal to 52.00 grams of chromium. Okay, and my next step in this situation is to set up my conversion table. I might have to go off the page a little bit. Hope everyone's okay with that. What on earth am I doing? That was just straight up wrong. Okay, so per usual, the given value that I got from the beginning is going to go in this top left-hand corner, okay? So that's 4.21 times 10 to the 23rd atoms of chromium. Okay, so next thing to do is I need to go from atoms, it looks like, to moles, okay? Because I want to end up with grams. So grams is actually going to be the last unit. This conversion factor is the one I'm going to use last because it's the one I'm going to end up with at the end because this is my find unit. So I'm going to put this in the very last box right here. Okay, so I want to end up with grams of chromium, so that's going to go on the top. Okay, and then on the bottom, I'm going to put moles. Okay, so, oh, actually, wait. Let me explain this again because this is not how I explained it in the video to you guys. Remember how we identified our given in our find kind of conversion factors? Okay, so this is going to be the, what do I have for, I'll use pink. This is going to, oh no, purple, what? God, I'm just a mess. This is going to be my, hang on a second while I get it together. This is my given conversion factor, okay? Because it has the same unit as the one in the given value, okay? Atoms and atoms, okay? And the given conversion factor goes right here, okay? And this is my find conversion factor, this one on the bottom, because it has the same units as the find, which is grams of chromium. And this one has grams of chromium, okay? And that one is going to go right here, okay? So I'm going to put my find conversions right in this center box, okay? So I'm going from atoms to moles in this case. So I'm converting 2 moles, so moles is going to go on the top. And then atoms is going to go on the bottom because I'm converting from atoms to moles. Okay, and that way these units cancel out. Okay, then my fine conversion factor is going to go in the very last box. I want to end up with grams, so I'm going to put the grams on top. And I'm converting from moles, so I'm going to put moles on the bottom. And those units cancel out. Okay, so what I'm going to do is I'm going to worry about these first two boxes straight off the bat. I'm going to do 4.21 times 10 to the 23rd times 1, and then divide that value by 6.02 times 10 to the 23rd. So if I do that real quick, I get around 0.70, okay? Then I'm going to multiply this value by 52 and then divide it by 1. When I do that, I get 36.37 grams of chromium. And that's going to be my final answer. So that means for every 4.21 times 10 to the 23rd atoms of chromium, I have 36.37 grams of chromium. Okay? So I hope this was a helpful review session for you. If you watch this and you still feel like you're having a hard time, please just let me know so that I can get you prepared for the quiz on Thursday. Okay? There is going to be some office hours on Thursday if you need to, so that we can review some stuff together. And feel free to set up a Zoom call with me tomorrow or Thursday if you want more individual one-on-one help. Okay? So I hope you guys have a great rest of your day and make sure that you email me with your questions.